In order to understand the content better in our session, I would like to hand over the control to Engineer Dinesh. He will explain you about the overhead distribution systems in Ceylon Electricity Board, so that we can build this topic in the coming slides better. So, Engineer Dinesh, over to you.
Thank you, Prabath. I think you can view my screen.
Yes, we can see.
Yes, as discussed, Prabath, we know how what will happen when the breakdown occurs. Before moving to the automation section, let's have a brief introduction about typical distribution network in Sri Lanka. Typically in Sri Lanka, other than in Colombo City and Kandy City, all over the area covered by overhead distribution network. Considering the reliability, the utility's main objective is to run the system in a ring configurations. Through the physical network is connected as a ring. During operation, always the network is operated radially by operating section lasers. However, due to various reasons, the network is constructed radially in special situation. Here you can see we have grid substation and another grid substation in other end. Sometimes this is not. And here we can see a MU distribution line, and also we can see in the distribution overhead system distribution substation. After the distribution substations, we can see LV distribution line. Finally, we connect end user through a meter and switch. And here I mark some squares. These squares represent switches. Now I'm going to discuss about that thing. Here in my diagrams, here you can see grid substation. This is the actual grid substations. The main function of the grid substation is it's convert transmission voltage into a medium voltage distribution voltage. In Sri Lanka, it is the transmission voltage is 220 kV and 132 kV. In the distribution, most of 30 kV, but in Colombo City and Kandy City and some other areas, it is 11 kV. And here you can see then we are talking about medium distribution network. And to see in every day, the distribution line runs over the whole line in everywhere. Now this figure shows intermediate switching point we call gantry. Gantry is used for the sectionalizing our distribution network. Now again, I am going to discuss what are the things in these squares. Actually, as I mentioned earlier, these are the switch. Here, this is the first switch. Actually, we can't say it's a switch. And the 90% of the connection made with the jumper wire, which calls a jumper point. That means the same conductor used for the connecting two sections. But if we want, we can open close manually during the maintenance and fault finding or times. We operate this manually. That it's time taken. However, it's not a operable switch. If we want, then we have to climb to the pole and open this point. But it's considered as a switch because of we can on and off. Then we can move to this picture. This is I think everyone have seen this one at the very close to the transformer, which is called DDLO, drop down list of switch. Actually, this is the main purpose of this one is not a switching function. It is used for the protection, overcurrent protection. But if we want, we can manually operate this switch by pulling and pushing on and off, by pulling and pushing by using operating rod. But the thing is, actually, this is not an on-load operation device. It is an off-load operation device. Then after that, we can see in our network system somewhere in this square. That means somewhere in this transmission lines. It's called isolator. The name implies it is used for the isolation of the system. But the thing is, this is an offload operation device. That means we can't open nor close when line is energized. Here, it's not like a jumper wire. We can operate. That means open or close by using operating rod. It's manually, or manually means that actually mechanically, or we can operate electrically by connect motor-driven unit to this unit. And also we can operate remotely by integrating motor-driven unit to the remote terminal unit. Then we can operate remotely. Then we can make automations when it's connect motor-driven unit and RPO unit. Then here again another switch we can see in the network. It's called air brake switch. Actually, it's a switch. It's not like isolator. We can operate this on-load condition. That means when line is energized, we can on and off. This is also normally operate with mechanically. That means this rod connect to the rod. These levers connect to the rod, and we can operate this rod by mechanically. And also we can convert into the electrical operations by integrating motor-driven unit. Again, if we integrated remote terminal units, then we can remotely. We can operate remotely. Then we can move to next equipment. It's called load brake switch. In the simple way, LBS, the same operations as the air brake switch, but the medium of arc pinching is different. It is SF6 gas. It's also mechanically operated switch. Also, it is we can control by electrically by motor driver unit 10. Again, we can operate remotely by integrating remote terminal unit. Then also we can see another type of switch is called auto recloser. This is also a switch, but I have to tell something. This is also on-load operator switch, but remember that during the fault condition, that means if there is any phase fault or earth fault, we can't operate these switches because of that much of current they can't handle. Therefore, this is only for we can operate only in the normal conditions, not the faulty condition. But when we move to this one, this is also another type of switch. As I mentioned earlier, it's called auto recloser. It is actually it is come with another intelligent device we call control box. Actually, control box is mainly consists of protection relay. It's always observe the condition of the system, and it's give the commands to the control unit of the auto recloser. And also this is very useful for the temporary breakdown. That means if temporary connect this to earth, that means it's touch if the line touch a tree, then it's a temporary fault, then it's detect, and then the control box send to command to this switching mechanism to the off, and we wait sometimes and again the reclose. That means therefore its name implies auto recloser. Now the fault is eliminated from the line, then it's permanently it can close. Actually, and other than we can normally we can operate on and off like a switch. The important thing is we can operate this is during the fault conditions. That's the important thing of the auto reclosers. These are the switch we can see in the overhead distribution line, ME distribution line. In addition to that, I saw another picture. This is called fault indicator. It is very useful for as mentioned, the Prabath during his presentation. He told if you can identify fault immediately by remotely, then we can on and off the switch if you have automated system. Then this is very useful for the identify the fault. Therefore, it's called fault indicator. This is also integrated with the remote terminal unit. Then it's communicate with the SCADA or other things. We will discuss more on in future. Then I move to the, we have discussed MV distribution network, then I move to the LV distribution network. Here you can see the main component of the LV distribution systems and actually intermediate equipment, it's called distribution substation. Mainly it consists of transformer. You can see here transformer. I think that we all are electrical student, and if not electrical, all know what is the transformer. Even small baby know transformer, what is the transformer. As I said, the transformer connected to the switch through a switch DDLO to the distribution line. Then the distribution voltage into the low voltage level. That means in Sri Lanka, 400 volt. When after that, this power delivered to the again overhead pole line. It consists 4 wire, neutral and other 3 phases, like the, as shown in the figure and as you have seen every day in everywhere. Again, I am again mark spares for discuss about the switches. As I discussed in the ME distribution systems, no more switch in the LV distribution system. Very simple, very few switches used in the LV distribution network. Then the practice is then the transformer output feed to a protection device called HRC fuse, so MCCB, shown in the figure. The function of these both are equal. It's like a fuse. That means if more current flow through this switch or this device, then we predefine the current. As example here, 400 volt. Then if exceed with the time, then it's open, automatically open. Here also it's open, but if you use fuse, when it's burned, we have to remove it, a new one. But if you use MCCB, we can, using this lever, we can again on. These 2 switches installed in the very close to the transformer. But in the sometimes in the spur line and spur lines, we use HRC fuse for the protection, isolation for the fault with spur line. Then again, we go along this LED distribution line. We can see another switch. Actually, I can't say switch, but again, I can say it's a switch. It's also jumper, as discussed in the ME distribution line. They are also jumper. The jumper means we can 2 lines connect with the permanent connection. It's called jumper. But when during the maintenance and fault finding times, we can open these jumpers by manually, and it's a time consuming thing. But for isolation and maintenance purpose, we use jumper wire. It is also everywhere in this LED distribution line. At the final end, that means end user supply feed with this switch we call fuse cutout. In the earlier we use fuse cutout. Nowadays we utilities move to the use here MCB. It is depend upon the type of the connection. It's 30 ampere, 60 ampere, single phase, 3 phase. Same function as in here. After that, the current passing to meter. This is an analog energy meter. We all know. I think we all have seen this analog meter. But now utilities replace this analog meter with smart meter because of now utilities move to the slowly move to the automated systems. I think now you have a good idea about the overhead distribution and overhead distribution system, MV and LV distribution systems. Then why automation is required for the distribution system and why it is? What is automation? So automations means we can integrate these everything, switches and meters to one central point, and we can monitor through here, and we can control remotely by gathering this data from one point. Then the automation, that is called automations. Then why it is at the beginning, Mr. Prabath said there are so many advantages of the automations. I am going to discuss only one about that one. Think your house is there, you are feed from this distribution substations, but in the some day due to the bad weather or another reasons, the fault is occur here. The fault is occur here. Then what will happen? Then the whole section, whole line get interrupted. Then the supply not supply to this form. But if then the normal system arranged with as I told earlier, actually it's a radial, but configuration like a ring. At one point it's open switch. Then what will happen? Then we call to the call center, and then the call center informed the breakdown. When they come to reach to this place after half an hour, 1 hour time, again they are manually open this switch as I shown. Then after that they reconnect open this T switch and reconnect this switch and supply fed to this home by through from this one. But if you have automated system, then once fault occur, we can identify. Then if we can operate this switch remotely, then within less than 1 minute, we can open this switch and we can close this switch and we can restore the power to this section as well as these sections. Then we can isolate only faulty sections. Then you can think about how time can reduce for the fault restorations. This is the one advantage of automations, but we have so more advantage. Now I'm not going to discuss about that. In the future, we will discuss what are those things. Right. The important thing is most of our participants are researchers. Then how automation helps researchers? We know during the research, the most important thing is the data. Without data, we can't continue research because of the outcomes depend on the data. Now, when we collect the data, if it is manual method, that means if you want to measure the reading, if you take the current reading continuously, then we have to assign somebody to read and record. Then we can think about the accuracy of that thing because of the human. If you intervention human, then the more errors, and also sometimes if there is no real-time data. Therefore, the most important thing is if we have automated system, then we can easily collect the data for our research. Therefore, the most important thing is for the researchers when a system is automated by collecting data. Then the output of the research become best way. Then the data is accurate and online data. Then I think we have a good idea about what is distribution network and what are the switch in the what are the components in the distribution systems. Then you can move to the automation systems. Now I am hand over to Chirantha for discuss about the automations.
Thank you, Dinesh.
We can see your screen now.
Yeah.
You can start.
Yes. Yes. Thank you, Dinesh. I am Chirantha Jayasinghe. I am also from Ceylon Electricity Board, and I have been working in this automation, or rather SCADA area for nearly 10 years now. And I should render my thanks to Professor Udayanga for giving us this opportunity. And I continue with the presentation as you now already have some idea what we are going to talk and what is the main requirement behind this today's topic. So as correctly it's explained, it's the communication. I think in the previous session also maybe we have covered that necessity. So with the communication, maybe it's two-way or one-way. It means bidirectional or omnidirectional communication towards the line equipment. Now, since we are talking about distribution today, so I refer the term, or I use the term line equipment. The line equipment are the things what Dinesh explained about. So here are the line equipment we normally come across, fault indicators, autorecloser likewise, and here are the meters and MCBs. So in an automation or remote accessing, when you are remotely establishing the communication, when we are going to have remote access for the network, so we are implementing the communication protocol. So depending upon the situation, depending upon the geometry or the complexity of the network, we have to choose a suitable one or two, maybe several protocol, hardware protocol, or maybe rather communication medium, depending upon. Now what we are chosen or what we have developed in our career was this is mobile technology. That means GPRS network we have been using, and the wireless network. So what we are doing is a kind of a retrofitting to the existing network. The ordinary equipments we connect with a computer system. We call it a SCADA. But for the time being, I refer it as a computer system. So we are interconnecting these equipment with a communication medium, maybe it a TCP/IP communication or maybe serial communication. So these are the now in your left hand we have the field devices, and the right hand we have the computer system, or rather the SCADA system. So to bridge these two entities, we are using communication layer. This is not the communication medium actually. On top of that communication medium, we are having other protocols. We refer them as utility protocols, namely DNP3, Modbus, like IC 101. Normally we refer this protocol as 101 and 104. And in some situations we use 61850 and DLMS COSM, and some other IoT protocols like MQTT and APIs, which our another partner is going to cover about. So these are the application layer protocols, rather than that communication protocols, GPRS or ZigBee or other protocols. So what are the communication protocols? This is actually a definition we quickly downloaded from Wikipedia, but what it explains is it's a set of rules, and it governs the communication between the remote devices and the computer system or the SCADA. So in addition to that, it encompasses that authentication and error detection, maybe in terms of hardware architecture, or most of the time it's a software built one. So with the communication, that utility protocol, now we are incorporating that utility protocols like DNP3 and those protocols I explained on top of the communication network infrastructure. So to comply with that protocols in the SCADA end or the computer I referred earlier, we will be having another protocol converter. We refer this as OPC server. For each and every protocol, actually we will be having not one OPC server, we will be having several OPC servers, and what it does is it converts this each and every protocol into an open or OPC standard, which enables the SCADA software to understand. So though it shows it's a one-way, the arrow points towards the SCADA, but always you have the other way as well. It's always bidirectional. What bidirectional means is you can always have controlling and observation together. That's what I wanted to emphasize. So we will be covering, maybe in future webinar we'll be covering this how to enable test setup, or how to build a test setup, maybe with a smart meter or auto rate closer. Maybe we can cover that stuff. So I'll quickly jump to to show you some of our real world examples. So this is an implementation in distribution network. This is from Battaramulla. So here, this is a video actually I have. This shows some networks in our distribution network. Some of the MV or medium voltage equipments have been connected to a SCADA screen, and this now here it shows how to excuse me. Now you have the ability to now, like I said, you have always ability to monitor or read the data available in the those binary equipment, maybe meter, auto recloser, or that meter. As you can see, you can read the voltage, currents, etc., etc., and you have the ability to switch on off. Maybe if it is a smart meter, you can even disconnect. Likewise, you have that access there. So for the time being, I will quickly jump on this, and now it shows now the red color ones are actually these are switch on position. That means the switch has closed to enabling this current flow in this direction. Now these are the equipments actually what Dinesh covers initially. Maybe these are not all, these are actually remote operable. Some are remote operable, some are only status can be received. Some equipment actually we don't have either. It means controlling and remote reading we don't have, but we accommodate them in our diagrams just to give the full view of the current status to be displayed in a screen. It means a bird's eye view can be given, like here. Now these equipments we don't have, like Dinesh explained, that now we have those air brake switches which we don't have the remote communication capability, but we have we can actually incorporated these as well. Without the communication medium, but just to have a mimic, you can have these things, and you can show the line energization status. That means, say, if the line get energized after the operation of some of the circuit breakers, you can indicate that in a SCADA system. Now we'll be covering these things in a detailed session, maybe in maybe few weeks later. And what I showed there, this is an enlarged screen. Now this shows an operating panel, what we are having in the field, but not with that detail. Of course, you don't get this much of cluttered data in a local panel, but in a SCADA you can have. But we have given the feel, look and feel to the user of the SCADA. So that is another aspect of building a SCADA. We always go with the or we always get the user in a comfortable position with their experience. Right. So I will quickly touch match the topic. It means automation. Now, actually, we didn't cover the automation in CV yet, or we are not using at the moment. But I will quickly describe what the automation does. Now, we already talked about the communication infrastructure and the computer system we are having. Now, we will be adding or incorporating another algorithm, one or two algorithms that with that we can automate. It means do some automatic operation, like Prabath in his video explained. So I think for that, I think we have enough room for researchers to come in and do the research. So I'll quickly show some real-world SCADA implementation in Sri Lanka. This is not distribution sector. This is system control center, and here also it shows some current status, and we can control even. So I'm handovering my session to again to Dinesh, to Prabath. Over to you. Thank you.
Thank you, Chirantha. Prabath, I think you can conclude the remaining part.
Thank you, Dinesh and Chirantha. So now, so far we talked about the distribution automation, and we talked about the all the line equipment, and the remaining is the smart meter at the households, and we have smart meters in distribution substations as well. So the motivation behind going for smart metering is because of its various advantages. I have highlighted few advantages here. The first thing is, of course, remote meter reading and remote disconnection and reconnection capability. So it is in line with the distribution automation. We have smart meters. We have to establish the communication. Then we can get data from the meter, as well as we can control the supply through the meter to the households. So on top of that, we can have automated outage detection from smart meters. We usually smart meters, when the power outage is detected, they send a message called last gas message. Using the last gas messages, we can identify the faulty sections we can identify the customers who experience outages. And from the utility side, our energy revenue will be improved because these meters are always accurate than the existing electromechanical meters. And we can detect the meter tampering activities automatically, and we can manage the transformer loadings because we can reconcile the energy by using the smart meter installed at distribution transformer, and using the data from the smart meters in the households of customers. So again, we will have data like load profiles and voltage profiles, which are useful for planning activities. And of course, for renewable energy generation monitoring, these meters can be used. And finally, the energy loss in the system will be reduced because of the accuracy, and again because of the non-interference of humans for meter reading. So the smart meters and the related systems in a utility network, we call it as automated metering infrastructure, or AMI. Usually the AMI systems are of this type of architecture. We are going to have meters. There are different kind of meters based on the communication technology they use. So on top here, we have GPRS communication type meters. They are going to be connected to the head-end system. That is the first receiving station of meter readings, and the commanding station we use to send commands to the meters. They will be directly connected. And we have another options like PLC, that is power line communication, and the radio frequency communication. In both of these types, we are going to need another additional field device called data concentrator unit. It is more or less like a gateway between the network this side and the network this side. So in the downstream here, the network is RF. In the upstream, it is IP network. So the DCU is going to bridge these two networks so that the communication can be established with the head-end system. In here also, the case is same. Here the communication medium is power line carrier. So it is totally operating in the utilities power lines. Then again, the DCU is going to have the same role of bridging these two networks, IP network and the PLC network. In PLC network, we have options like narrowband PLC and broadband PLC. In RF also, there are different kind of protocols like ZigBee, LoRa, etc. So let me put all these things into a pictorial words to explain it a little bit. So at the household, we are going to have energy meters, and in a very smart systems, we are going to have in-home displays, which I have shown here. Usually the energy meter is going to be at a wall outside, looking outside the home. So in order to the residents to see their consumption, this kind of in-home display can be kept inside home in a visible location. And there can be smart connected appliances like maybe air conditioners or refrigerators. And in more generalized form, there can be connected socket outlets like this I have shown here. So these socket outlets, they are piggyback sockets. we can plug them into the normal 13 ampere socket outlet, and on this device we have facility to connect our loads. They support monitoring the load as well as disconnecting the load, so that utility can, with an agreement with the customer, utility can limit the loads and monitor the loads. So all these devices, this kind of sockets and in-home displays are going to be connected to a home area network with the meter. So at the central system end, we are going to have the head-end system and a meter data management system. These are the components of industry standards AMI systems. So whatever the data generated from these devices are going to come into the head-end system and meter data finally to the meter data management system. The head-end systems are usually vendor specific. So for a particular brand of smart meters, a particular head-end system is going to be introduced to the utilities system. So in order to have the communication between devices at home and the central system of the utility, we have to have the communication. As I explained earlier, there are two options: DCU based communication and direct communication. Here I have shown a DCU. One of the DCUs we used in a pilot project in CB. So in DCU based architecture, we see communication protocols like ZigBee, PLC, and LoRa. In direct communication, meter has a communication module, GPRS or 3G or 4G type communication module inside the meter, and that through that module it is going to be connected to the central system. So as Chirantha also explained earlier, there have to be application layer protocols in order to bridge all these stuff, central system and devices at home. So in smart metering, DLMS COSEM is the industry standard protocol suite. There are other protocols, but as of today, DLMS COSEM is more or less the standard. So when we are moving forward with smart meters, we purchase smart meters which comply to this DLMS COSEM protocol suite. It is actually not a single protocol. It has many number of protocols which describe the various aspects of smart metering. So with that, I would like to show you some demonstrations about the smart metering aspects we implemented in-house in CEB. So a requirement came from our National System Control Center regarding a method to monitor the generation of NCRE power plants. NCRE stands for the non-conventional renewable energy power plants. So power plants like mini hydros, small grid scale like 10 megawatt solar power plants, and wind power plants are in this category. And most of these plants are located in remote areas, and most of these plants do not have SCADA systems, inbuilt SCADA systems. So the solution we came up with is to use the existing billing energy meters at these locations. So these energy meters support different protocols like DLMS COSEM, and Modbus. So we developed a device, small device, a simple device which can read the meter using the Modbus protocol, Modbus TCP protocol to be precise, and then transfer that data into our head-end system using GPRS technology. So the system is something like this. Rather than explaining all this stuff, I will show you real life data we are receiving from these systems. So I think my screen is visible to you.
Yes, Prabath, we can see your screen.
Okay, thank you, Dinesh. So in this system, this is the head-end system web interface. So we are covering like 40 number of remotely located power plants which do not have SCADA systems, which supports the direct integration with the SCADA system of our National System Control Center. So this is here you can see the power generation profile of the mini hydro, solar and wind power plants today, from today midnight up to now. That is I reloaded this page in 1830. So you can see that because of these rainy days, we have a lot of mini hydro power. It is almost continuous, and mini hydro power plants are running at their peak, and in cyan color some wind power throughout the day, and in the daytime from the yellow color you can see the solar generation. So if we go deep into and see the generation of a particular plant, this is one of the solar power plants located in Hambantota Solar Park, a 10 megawatt power plant, and this is that plant's generation today from now to the yesterday this time. So you can we are collecting data every 1 minute so that you can see the behavior of the power output of the plant very precisely. So likewise, there are different kind of plants. This is a wind plant. You can see the variations of wind generation, and of course this is a mini hydropower plant. They are running at their peaks, almost at the peak power. And of course we have this is again another mini hydropower plant running at the peak power. Likewise, this is a run of the river type mini hydropower plant. Likewise, we are collecting that data by implementing the distribution automation, one of the aspects of the distribution automation. And this data is useful for system operations.